What if I told you that no matter how fast you run, no matter how far you go, you can never really reach the finish line? Sounds absurd, right? But this puzzling idea was first proposed over 2,000 years ago by a philosopher named Zeno. His paradoxes challenge some of our most basic assumptions about motion, space, and time. So today, we're diving into the mystery of Zeno's paradoxes. Are we really moving forward, or is the finish line forever out of reach? Zeno of Elea, a Greek philosopher from the 5th century BCE, proposed a series of paradoxes that have baffled thinkers for millennia. His most famous one, the paradox of Achilles and the tortoise, goes like this. Achilles, the fastest man alive, gives a tortoise a head start in a race. Even though Achilles runs much faster, by the time he reaches the point where the tortoise started, the tortoise has moved a little farther ahead. Every time Achilles reaches where the tortoise was, the tortoise has moved again. So in theory, Achilles never catches the tortoise. Zeno's paradoxes suggest that motion, as we understand it, might not even be possible. If we have to cover an infinite number of smaller distances to get anywhere, can we ever truly reach the finish line? At stake here isn't just a simple foot race. Zeno's paradoxes challenge our understanding of infinity, space, and time itself. Let's take a look at how philosophers and mathematicians have tried to resolve Zeno's paradoxes over the centuries. First, we have Aristotle's response. Aristotle argued that Zeno's paradoxes confuse the idea of infinity. While it's true that distances can be divided infinitely, that doesn't mean the sum of those distances is infinite. In other words, yes, there are infinitely many points along a racetrack, but that doesn't stop Achilles from catching up to the tortoise because the time it takes to reach each point decreases with each step. Then came calculus, developed by Isaac Newton and Gottfried Leibniz in the 17th century. They introduced the concept of limits, which showed that an infinite series of smaller and smaller distances could indeed have a finite sum. This mathematical breakthrough seemed to resolve Zeno's paradox by showing how Achilles could catch up to the tortoise in a finite amount of time. But not everyone was satisfied. Some philosophers argue that these solutions don't address the deeper philosophical problem. The Eleatic view, which Zeno himself supported, questions the very nature of motion and whether space and time are continuous or made up of discrete, indivisible units. If space and time are continuous, the paradox holds. But if space and time are quantized, like pixels on a screen, perhaps the paradox dissolves. More recently, some physicists have used ideas from quantum mechanics to suggest that motion at very small scales might behave differently than Zeno imagined. At the quantum level, particles don't move continuously but in discrete jumps. Could this mean Zeno was wrong all along, or was he onto something far ahead of his time? Interestingly, Zeno's paradoxes still spark debate in the world of modern physics and mathematics. Some of the most cutting-edge theories, like Zeno's quantum effect, explore how particles can seem to freeze in place under constant observation, a phenomenon linked to his original ideas about motion. Additionally, in cosmology, questions about the nature of space-time, whether it's continuous or made of indivisible units, are still being explored in theories of quantum gravity. Mathematicians also continue to refine how we think about infinity, particularly with set theory and the concept of actual infinity versus potential infinity. These ideas are critical for fields like computer science and artificial intelligence, where dealing with infinite processes is part of solving complex problems. So, while we might feel like we've solved Zeno's paradox with calculus, it still pushes the boundaries of how we understand motion, time, and space. Zeno's questions are as relevant today as they were over 2 millennia ago. So, can you ever really reach the finish line, or is Zeno's paradox still holding us back in ways we don't yet fully understand? The paradox challenges the very fabric of reality, and maybe the answer isn't as clear-cut as we think. I want to know what you think. Can motion, space, and time really be broken down into tiny, indivisible parts, or are we just scratching the surface? Let me know your thoughts in the comments below, and don't forget to subscribe for more journeys into the unsolved mysteries of the universe.